Okay, honors chemistry. This is the day 5 lesson. It's the third lesson. These dates reflect period 1's due dates. Again, they're off between the two periods. Those end up evening out by the end of next week. So these dates are for period 1 only. Period 3, you have not even gotten this assignment yet. You'll get it in the next class session. So I'm going to go ahead and walk you through this assignment and do some of the problems, and some I'll leave for you. Okay, so the first set of problems is identify the number of significant figures. Write the number to the correct number of significant figures. Okay, so for example, this number has a decimal point and 1, 2, 3 significant figures. The leading zero is not significant, so the answer is 3. So the answer to this, it's going to have 3 significant figures. So the answer to this would actually be 0.140. That would be the correct number of significant figures and the actual number. All right, let's move on to this one. Okay, this one has the leading zeros are never significant, so 8, a middle zero in between 2 non-zeros is significant, and 6. So this has, these 3 are significant right here. And so that's going to be 3. And the answer is going to be 0.0806. That would be the correct number of significant figures and the number. All right, this one, 23.0010, has 1, 2, 3, 4, 5, 6. All of them are significant. All the zeros, this one is significant because there's a decimal point. So we're just going to simply write this number out again. All right, this one, it has 1, 2, 3, 4. These are the significant figures. Leading zeros are never significant, so that's 4. And the number to the correct number of significant figures is going to be what you see there. All right, 20,300. All right, so this is significant. The 0 in between the 2 and the 3 is, and the 3 is. There's no decimal point, so these 2 are not significant. So that's 3 significant figures, and that's going to be 20,000. You can write it with or without the comma. 300. So that's the correct number. Okay, this is going to be 200220. So that's going to be 6 significant figures, and it is what it is. None of these are going to change in terms of what the value is. That happens when we do a multiplication. Okay, so I'm just giving you that. So really just identifying the number is satisfactory. Okay, 100200. All right, there's no decimal point, so these 3 are not significant. These 4 are, so that's going to be 4 significant figures. Commas are optional. Usually a number above about 10,000, you do write the commas though. And you start at the wherever the decimal is, and you count back 1, 2, 3 digits, comma, 1, 2, 3 digits, comma, and that's how you would do that. I'm going to leave the last 2 for you to do. Just identify the number of significant figures. You don't need to rewrite the number. Okay, let's go down here. Let's do some multiplications. All right. So I'm going to do a few of these right here. So 0.0021 times 2.0108 equals, and it's going to equal this. All right, now we have to start limiting. So the significant figures you see here is 1, 2, 3, 4, 5, 6. Up here, this number has 1, 2, 3, 4, 5, and this one, these are not significant, only has 2. So this can only be to 2 significant figures. Okay, now you still have to write the leading zeros. So it's going to be 0.00, then it's 422. Those will be our 2 significant figures right there. So the next digit after that is our rounding number. That 2 is going to round this 2 back down to a 2. So it's going to be 42. Okay, and now we have 2 significant figures. So 2 sig fig and 2 sig fig right there. Okay, there you go for that. That's your answer right there. Okay, how about this one? It's 20,000. That only has 1 sig fig. This one has 5 sig fig. So we're going to multiply that 20,000 times 1.0478. Click on that. And this is the calculator answer. But it only can have one significant figure. That's this one right here. So the next digit rounds, the 0 rounds down to 0. So your significant figure answer, this does seem a little strange when you first do it, is 20,000. Okay, that's it. You can put the comma if you would like. Okay, this should be a decimal point. Okay, this one comes out to be, on the calculator, 0.000023. Alright, and you can continue to write zeros if you would like. Because this one can have 1, 2, 3, 4 significant figures. This one can only have 1, 2, 3. So the answer is going to be 3 significant figures. So it would be this one, and that 0 that I decided to add on. My calculator didn't show that, but you can write zeros after that forever. And that's going to be 0.000023. Those are the 3 significant figures that you're allowed to have. 3 SF. Okay, let's add a couple here. So let me draw a line here. So to add, we've got to put the numbers on top of each other and line up the decimals. And 2.8. And then we're going to draw a line right here because that's the least number of digits after the decimal point. Remember, totally different rules for addition and subtraction. So now we add everything. Okay, so those are your significant figures right there. And this rounds this last one right here, and it's a 0, so it stays at 3.1. So the answer is 3.1. Okay. I'll do this one, and then I'll leave this one. This is a U problem. U. Okay, so this is going to be 200.98 plus, and we got to line up the decimals, 44.0478. The line goes right down besides this digit because it's the least number of digits after the decimal. So this becomes an 8 and a 7 and a 12, carry the 1, and a 10, carry the 1, and a 5, 4, 2. And the decimal comes straight down to right there. All right. So this 7 is the rounded digit. It's going to round this 2 up to a 3. So your final answer is 245.03. All right, I'm going to leave this one for you. And I'm going to leave this one for you. So remember, you're going to do, we'll do this one in class, okay? Let's do this as a class, because they only gave you one that was a combination problem, so let's just do that one in class. Okay, just a reminder what you're going to do. You got to do PEMDAS. You got to do the multiplication division first. Once you got that number, then you go from left to right. You add this plus whatever that is. You can put this in parentheses if you'd like and write first. You're going to do that first. Then this minus whatever you get from that. And then once you get that, then you subtract this. All right, so that's the PEMDAS. Okay, good. Let's keep going. Okay, 2 logarithm problems, and I'll do one, I'll give the other. So this has 3 significant figures. So you're going to go to your calculator and you're going to compute the log of 32.1. It's a common log, so it's a base 10. So I'm just going to hit log 32.1, and it gives me 1.5065. That's as far as we need to take it. So it's 1.5065. And since it has 3 significant figures, you go to 3 places after the decimal. It's just the way it works with logs. Don't ask why. It just is what it is. So the final answer is that. Oops, I take that back. That 5 rounds that up to a 7. So it's that. 1.507. Okay, you go ahead and do this one. All right, measurements. The interval from 5 to 6, so here's 5 centimeters is right here, and here's 6 centimeters right there. So this is 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6.0. Okay, so the interval from 5 to 6 centimeters represents 1 centimeter. The small lines are millimeters. That's these. These are millimeters. Write the proper measure for each arrow below. So remember, you can do it to the nearest millimeter, plus you get to guess one more digit, okay? You get a guess digit. So this, it's 5.0, because it's not the 5.1. Why don't you write this down? Just be sure you're clear on what each of these lines is. It's 1/10 of a centimeter. Okay? That means you can not only write it to one place after the decimal, but actually a second place based on what you think that is. All right? So let's do a few together. So let's just do a few. Let's fill in a few of them, and then it's asking which of the following are possible measures on the scale above. What do you think this is? If this is 5.0, this is 5.1. What is that? You might say 5.6, you may say it's a 0.6 or a 0.7. In other words, if this is 0, this is 1, then that's maybe a 7. So it's going to be 5.07. It's the second place after the decimal. So I'm just going to guess that that's about 5.07. How about this one? Okay, it's right on 5.2, but you still show that second decimal place, 5.20. You're saying it's neither a little bit to the left or a little bit to the right. It's right on that line, 5.20. Let's try this one. What's that? It's 5.3 something. It's before 5.4. I'm going to say it looks like about 5.35. It's that second digit, I think, is halfway between there and there. So 5.35. Okay, so now I'm going to actually do what the question's asking for. Which of the following are possible measures on the scale above? 5. No. There's nothing, none of the red arrows is pointing to that, so I'll just lightly do that. 5.1, no. There's nothing pointing right to that. 5.90, not quite. This isn't right on 5.90. I'm going to say no on that. How about 5.550? Well, there's nothing right on 5.55, but this would be wrong anyway because you can't go to that extra place. You can only go 2 after the decimal. Again, this is 5, this is 5 point something, 5.1, 5.2, and then you get to guess if it's somewhere in between. So I'm going to say no for this entire thing, but because of that. 5.32. It doesn't look like anything is there. Okay, so no. 5.999, again, too many digits. 5.0, no. 5.49, I get a big no there. I think maybe none of these were. So I think maybe what I was getting at is which one, just based on the number of digits. So this can't be because it's not 2 places after the decimal. This one can't be. So, see, I'm trying to understand my own question. This is 2 places after the decimal. So even though you don't see a 5.90, you can go ahead and say, yes, that's a possible measure with that many digits of precision, 2 digits after the decimal point. This one, no, we said. This one, yes, it could be. It's 2 places after the decimal. This one, no, it's 3 places. Can't do that. 5.0 could be, and 5.49 could be, even though none of these are that. But let's go ahead and fill this in. Okay. So that, I'm sorry, I wrote that question, forgot what I was trying to ask you. Okay, so next, this one, it's going to say, I'm going to say 5.51. I'm going to say it's just after that. But again, it has to be, all of these have to be 2 places after the decimal. This one, 5.7. You could say 2 or 3 maybe for that one. I'll go ahead and say 3. Either one would be, it's your best estimate of what that last digit would be there. Okay, and finally this one, it's just before 5.9, so it's 5.89, I'm going to say. All right, you get the idea on those? All right, good. And then we clarified what I was asking for there. Okay, let's keep rolling here. Okay, each of the short lines in the cylinders represent 1 millimeter, which is also 1 cubic centimeter. It says give your best estimate of the level of each cylinder to the proper number of millimeters. Now, one thing you want to notice is, let's see. Well, all of these are cylinders. On the next page, I'm going to show you one with a burette, and you're going to see how it's different. But I'm just going to do one of these. I'm going to let you do the rest. Okay, so this one, here's 80, here's 90, and notice the numbers are going up. So this one is above 80, so this is 81. This is 82, and you can see the line there barely, it's 83, but it's not all the way up to that line. So I'm going to estimate that's 82 point, I don't know, you get your best guess. I'm going to say 82.7, maybe 0.8, you give your best guess. So I'm going to call that 82.8. Okay, and the unit of measure is milliliters. Okay, so each line is 1 milliliter, and in between is going to be 0.8 milliliters. All right. Now I'm going to let you just do these. I think you understand the concept. It's kind of hard to see sometimes where the bottom is. That one, the bottom is a little bit below the line. That one looks like it's pretty close to being right there on the line. You make your best judgments on those. Okay, we'll talk about them in class. All right. So here is a couple of more, but notice something about this one. In all the other ones and on the previous page, the numbers are going up as you go up. That's something called a cylinder. You fill it up. So as you add more and more liquid, it goes from 20 to 25 to 30. Notice this one's in the other direction. As you go down, it becomes 1, 2. The numbers increase as you go down. That's called a burette. It's used for a process called titration. And what you want to know is not what is it filled up to, but how much of it have you used? How much of it have you dripped out? So when we get to titrations, you'll understand that concept. But in this case, the liquid is going down. It's going drip, 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 and the level of the liquid is going down. So again, you estimate the same way. Just remember that on this one, the numbers are going up. On this one, there's 1, 1.1, 1.2, 1.3, and so forth. So the numbers are going up as you go down on the level. All right? Okay. Next one. Hopefully this one's not too hard. Parallax. Parallax is when you don't read your glassware straight on. So it occurs when a piece of glassware is read from an angle, so the meniscus does not line up properly with the lines. So which student, the boy or the girl, is reading the cylinder from the correct angle and why? So I think you can answer that one. So go ahead and just write that explanation out there. All right. Okay, in the video I showed you how to read a triple beam balance. So the biggest number in the hundreds is here, then the tens is here, then the ones is down here, and then the small lines are point something, so 3 point something. And then again, you have a guess digit. So you're again going to go 2 places after the decimal when you write down your reading for this. All right, so I'm going to let you go ahead and read these two on those two. All right, next. Okay, something to think about. Convert 1 milliliter to liters using the conversion. Okay, so we've done unit conversions before. So we're starting with the number they want us to start with is 1 milliliter. And the number they want us to end up with over here is some number of liters. Okay, and then we have this conversion, so we're going to write it both possible ways. There's 1,000 milliliters for every 1 liter, or equally true statement, there's 1 liter for every 1,000 milliliters. All right, so I did this. I got my box here. All right, so I need milliliters to cancel out and liters to appear in the final answer. Which one of these two do I want to use? I want to use this one with milliliters on the bottom and liters on the top. 1 liter for every 1,000 milliliters. So milliliters on top cancels with milliliters on bottom. Last man standing. So 1 divided by 1,000 is this, 0.0, that's the tenths position, 0, that's the hundredths position, and 1, that's the thousandths position. So that's 1 over 1,000 in decimal form is 0.001. Okay, write a brief statement explaining why leading zeros you have on the liter measurement are not significant. So think about it. Here I'm going to kind of give you the clue or the answer here. Why are these not significant? I mean, that's definitely a different number than 1, but why is that not significant? Because if they were significant, it would be implying that you've measured this to greater precision than this. But did you do that? Did your measurement become any more precise just because you decided to convert from milliliters to liters? Did that make the measurement that you made in the laboratory of 1 milliliter more precise? No. It didn't become any more precise. You just decided to do a unit conversion from milliliters to liters, and so you have those leading zeros. But if these leading zeros were significant, you would be implying that this is a more precise number. 1, 2, 3 significant figures, or even 4 if you counted that one. 3 significant figures would be more precise a reading than this, and it's not. Just doing a unit conversion doesn't make your measurement more precise. So I want you to think about that, and I want you to put that in your own words down here. Okay, that takes care of it for this answers video. It's fairly quick, and go ahead and do that, and try to have that done by Monday if you're in period 1, and if you're in period 2, you haven't even seen this yet. Okay, so we'll get to that at a later time. Okay, have a good day. We'll see you in class.